All right, so today's lesson is going to be on translating some words into mathematical expressions. So, in order to do that, we have to first list out some of the most common words that are used for the four operations: add, subtract, multiply, and divide. And then once we have that, once we have a list of some good terms that are used for each of these operations, we're going to go ahead and do a couple examples together, and then we'll see where that's used. So for addition, a lot of the words that you hear are things like total, sum, more than, what else is there? Plus, and increased by, or increased and then increased by. So if you see those, that should automatically click in your brain, okay, I'm probably going to have to do addition. For subtraction, there's always the difference. The difference is the answer to a subtraction problem. There is decreased. There's just minus. There's fewer. There's less. And then there's less than. And that goes along with more than, but more than is a little bit easier because in addition, you can reverse the order and it doesn't really matter. With less and less than, we're going to do an example where it's really important which one we're using because it'll change the order in which we do things. So that's add, subtract, multiply. We've got, just straight up multiply is one of them. Times is one. Product is another. Factor is another. Let's see, any other ones? I don't think so. We'll say multiply is a big one. Multiply, times, product, factor are kind of the big words for multiplication. Divide, of course, we have division. We have divisor. We have quotient. We have dividend. We have per. Per can kind of go back and forth. We'll put it in kind of both categories here. It can kind of mean either one. It kind of depends on the context of the problem. All right, so make sure you got this list down in your notes because this is super important for when we go through some word problems to translate. It's kind of hard to see the D in difference here, but make sure you have these down and make sure you know that per kind of goes to both of those there. So the first couple word problems that I want to go through are just literal translations, translating a bunch of words into an expression or an equation. In this case, it's going to just be two expressions. So the first one is kind of like I mentioned with the less than in there. So the first thing that you should be thinking, okay, less than, that's in my subtraction category. When you see this than, this is a mistake that a lot of students make. Whenever you see that than, you actually have to switch the order of these numbers when you write it out. It's kind of confusing because if you wanted the number that is 3 less than 7, well, the number 3 less than 7 is 4. And how do you get 4? You have to do 7 minus 3. If you did it the other way, 3 minus 7, you get negative 4. So you got to be really careful. You got to think about it a little bit. You can't just go up to it and say 3 less than 7. Well, less than is minus, 3 minus 7. Think about what number you're actually looking for there. 3 less than 7. Okay, I'm looking for 4. So I get 4 by doing 7 minus 3. All right. This next one here, got an S in it. This next one here is kind of a multi-stepper. So it says 2 times the sum of 4 and 10. So there's two buzzwords in there. There's 2 times and sum. So we've got two different operations. We've got multiply and we've got addition. So where it says 2 times the sum of 4 and 10, we're not just going to be multiplying 2 times 4. We have to add 4 and 10 together first. So we know that we're multiplying by 2. And then if we just did 4 plus 10, well, order of operations, we just talked about that. 2 times 4 would go first. So I want to multiply 2 by this sum, so I want to do the sum first. So how am I going to get it so that I get the sum first and then multiply by 2? Well, our first step in order of operations says to do parentheses first. So if I add parentheses in there, well, then I know to do the parentheses first, add it together, and then multiply it by 2. And in case you were curious, this would be 2 times 14, which would equal 28. Okay, now we're going to start introducing some variables when we don't know what a number actually is. So in this top one here, 4 more than, so right off the bat, I see that more than, I'm already thinking addition. So 4 more than, it's a bad plus sign. The quotient, what operation is quotient? It's division of a number and 7. So there's a lot going on in this one. 4 more than. Again, once you see that than, you got to remember to switch the order. So this 4 is actually going to be going at the end because we're adding it at the end because it's 4 more than whatever the rest of this says. So I'm already going to put the plus 4 at the very end. Then I've got the quotient of a number and 7. Does it say what that number is? It doesn't. So we can kind of just give this number a name because we don't know what it is yet, but we want something to keep its place. So I'm going to call it x because that's just kind of my go-to variable. I'm going to say that number is x. So the quotient of a number and 7. So quotient meant divide. So I'm going to say the quotient of a number and 7 is just x divided by 7. Now you can write it like this if you want to. You can also put it in parentheses, x divided by 7 plus 4. Mathematically speaking, this top one looks a little bit nicer and it's going to be a little bit easier to work with than this one here. So x divided by 7 plus 4 is the same thing as 4 more than the quotient of a number and 7. All right, so we're already introducing some variables. So this bottom one here, 2 times a number less than 12. So we've got times, which we know is multiply, and we've got less than, so we've got subtraction in there. And remember, since it's less than, this first part is actually going to go at the end. So we already have that minus in there. So let's do this first part and put it at the end here. 2 times a number. Well, again, we didn't know what the number was. But this time, let's call it whatever we want. Use your favorite letter. I'm going to use G for obvious reasons. So 2 times a number, G. So 2 times G. 2 times G. And remember, once we have that times, we don't really need that dot in the middle. That just becomes 2G. So 2 times G, and that's less than 12. So we have that minus 2G already. So to get this front part, we just have 12 minus 2G. 2G less than 12. 2 times a number G less than 12. All right, so the second half of this video is actually going to switch gears a little bit. So once we get that expression, once we've translated it, we want to use it in certain ways because in real life, we're not just going to translate stuff and then never use it. We want to be able to use it in different situations. So what we're going to practice is evaluating expressions when we're inputting numbers for a variable. So this first one up here says evaluate. Evaluate is just a fancy word for multiply all the way out to get a final answer, or do all the operations possible to get a fully simplified number. So this first one, evaluate 3f minus 4. Another way you could read that is 4 less than 3 times a number f when f equals 5. Well, what does this equal sign mean? What does it mean for two things to be equal? It should mean that you can substitute them out. So if f and 5 are the same, where you see f, you can replace it with 5, and that expression will be the same thing. So that's exactly what we're going to do. In this expression here, I'm going to substitute 5 where I see f. And remember, when a number and a variable are squished together like that, that's called the coefficient in front of the variable. Those are multiplied. So this becomes 3 times 5 minus 4. And then all I have to do is evaluate. And this is where our order of operations practice comes in really handy. 3 times 5, well, that gives me 15. Minus 4, my final answer is 11. So not too bad. You're just substituting in where you see that letter, you're going to substitute in the number that it's equal to. So in this bottom one here is a little bit more complicated. We've got evaluate or solve all the way out for 2a squared plus a minus 5 when a equals 3. So again, where I see a, I'm going to plug in 3. So right away I've got 2 times 3 squared. I got to keep that squared in there. Plus 3 minus 5. Order of operations means I do exponents first. 2 times 9 plus 3 minus 5. Then I multiply. 2 times 9 is 18 plus 3 minus 5. 18 plus 3 is 21. 21 minus 5, that gives me 16. So in this video, we did a couple of different things. We translated words to an expression, and then once we have an expression, we can use it to evaluate at different inputs. And this becomes really useful when we look at things like economics and plugging things in and supply and demand, when we have to figure an expression for different inputs, for different things that we could plug in to try to see which one's going to give our maximum output or minimal usage. All right, so make sure you've got good notes on this because our Delta Math is going to be a little bit trickier in this time around.